Hello and welcome to all of you from the RBS Busy Research Academy. My name is Dr. Rahim Baksh Somro and I'm from Shah Abdul Latif University, Pakistan. This is the video lecture number 4 in which we are understanding that how we can compute descriptive statistic and the graphs in the Jamovi. Dear viewers, it is very easy to compute the descriptive statistic like the mean, mode, median, standard deviation, minimum, maximum range, and all these values as well as the graphs in the Jamovi. So how to compute? First of all, we have to look at these three lines are there. Just click it. When you click it, then you will find these options are there, and these are our data set on which I have already worked. So if you know about all these options and these menus like this one, then my video lecture number 2 is available. It would be better for you to watch this one and then watch this one. And it would be better that if you watch that video lecture number 2 before watching this lecture. So now how to attach the data file is very easy. Just open data library. Already these files are here which are being given to you from the Jamovi software, but we want to upload or attach another file from our computer. So that's why it is select this PC and then browse. If you browse it, then you will find that these two data sets are available. This one is in the Excel with the .sav extension, and this is the SPSS file. So now if you click it, that all these type of the files are there which normally Jamovi accepts. So now we have to click it and then we have to attach this one. Just open. Okay, just select it and then open. Now the file has been attached with our Jamovi file. Now we have to provide some we have to do some coding behind all these variables, because now you are looking here to all these numbers are here, but we have to provide some codings to every variable like this one. So now these are different options are there for which we can provide the coding to each variable. So now I think it would be very lengthy process if you provide the detail to every coding to every variable. And by the way, how to provide all this coding, please watch my lecture number 3 on the Jamovi. And then I think if we import the SPSS file, then I think we are not required to do some coding in this one. So it is better to attach the SPSS file with the Jamovi. So now we're doing that thing. To attach this one, we have to open in a new one. Just open, click, and then delete the last one and then attach. So now here we are going to attach the SPSS file. Just the same process, open and then go into the SPSS. And then we have to, now if you're comfortable with the SPSS, then I think it would be better always to attach the SPSS file with the extension of the .sav instead of attaching the Excel file. So now select it and then open. Once if you select it, okay. Oh, now the unable to open. The reason is that why we are unable to open it. I am telling you its solution, because the same file is open right now. So that's why we have to delete this, and then if you do now the same process, you will be able to attach the file without any problem. Browse and then select and now then open. So now the same file has been attached, and now you're looking there is a proper coding with every file. So now you are not required to do any coding behind the every variable. All the coding have been done with this one. Okay, and what I will do is at the end of this video, I will compare the results of the Jamovi with the results of the SPSS. As we should be confident that whatever results which are getting in the Jamovi, either those are correct, are in the line with the SPSS results or not. Okay, so now we have opened our SPSS file also. Now Jamovi is there. So first of all, we have to provide some descriptive statistic tools. So now it's just very easy. Jamovi is really is a wonderful, like a magic software. Just descriptive statistic, and then you look. There is a by default the results are. Now these are variables are there. Now these variables have been selected by default from the Jamovi. Whenever you will work, now these are by default selected by the Jamovi. Other like see here. Now see, because all these are selected by the Jamovi itself by default is been selected, so that's why you are looking here. So now we have to shift the data from the this column to the variable. Now what to do? Select QPE1 and then select the shift button. Press the shift button and then press the last one. In this way, all your variables will be selected in the one go. Okay, this one is out. If you want to search out any particular variable, you can also search through this method and then just click it. Okay, now you're looking instantly. We have got results. So now really it's a magic of this software. Otherwise, if you are required to do work in the SPSS, now what? Then you are required to go into the like the analyze and descriptive statistics and then frequencies and select all these one and move those from here to there and then go to the statistic and provide all the, and then the software will be able to compute the descriptive statistics for you. So now, but instantly you are getting the results of your descriptive statistic tools here. Okay, so the results you are getting which have been selected by itself. Now some other we want to select like the percentile value 4. Okay, 4 equal groups are there. Now the 25th, now 50 and 75th. Now mode and the sum. So now as you are selecting the options, in the same way you are getting the results. So that is the beauty of the Jamovi. That's why we call Jamovi as a user GUI, graphical user interface. If you perform the same work in the R requires from you to provide some codes. So now here you are not required to do any codes. So now free, but everything is there. Okay, and then this dispersion, variance, range, minimum, maximum already have been selected, and distribution, skewness, kurtosis, and test of normal. Your data is normal or not. For this purpose, Shapiro built test is there, mean dispersion, and then if you select them. So now everything is you are selecting the result you are getting here. So now to compute the results, describe how it is easy. That means you know from this one, very easy. Okay, so now how to understand, that is another thing, but how to compute, that's very easy. So now all the results are here. Now like the n number of observation missing, zero missing are the mean standard deviation, and each and everything is there. But always as apart from the analyzing or looking the other values, I always prefer to look at the values of the range, minimum and maximum, because these are telling you either there is an outlier in your data or not. Okay, for example here 1 to 5, minimum is 1 and 5 maximum is 5, because I'm working on the 5-point Likert scale where 1 is strongly disagree and 5 is strongly agree. So that's why the minimum is 1 in the QPE 1 and the maximum is 5. So if you talk about the range, then the maximum minus minimum, it will become the range. Here range is 43. Oh, quite a different unique, let me say, value you are getting. Probably there is a one issue. The issue of what? The minimum is 1, maximum is 45, 44. It means there is a problem in your. So now somewhere, the probably what I understand is that instead of inserting the 2, probably there are 2 times the 4 letter has been pressed by you. That's why there's a 44. So now there's an outlier because it is out of the range of the 1 to 5 point Likert scale. So now in this way you can find out the issue. Okay, the issue is also here. Maximum is 1, 9, maximum is 8. So some issues are there. In this way, at least you will be able to find out what either there is any outlier or not. So that means there's a very good point to find out the outliers. Okay, so now it's all about the descriptive statistics. But now if you want to if you do not want to get this one, then select deselect all these one, and then automatically or by itself these will be like the disappear, like you're looking here. How is that easy? Okay, and then Some. Okay. In this one more thing. Frequency table. If you want to get frequency table, just click it. Automatically, the frequencies tables will be available for each variable. So now you're looking for each variable. Now in this way, the FQ2 strongly agree are 6, disagree are 27, neutral are 65, and agree are 106, and strongly agree are 52. Their total and their community percentage is also there. So now like the frequency tables for each variable are there. Okay, and now we want to do some more work with the plots. So in this one, the plots are there. The four types of plots are there. Histogram is there. Box plot, bar plot, and the QQ plots are there. Just you are required to select it. Automatically, the histogram for each variable will be computed. Okay, and then you are required to come down. Okay, first I think we should not we should deselect this frequencies table. This will disappear, and now we are getting the histogram. So histogram SQ2, again there is one problem because that is out of the range. 40 is there somewhere. This one is showing that the 40 is there, so the outlier is there. And then you're looking again another outlier in the QPE2. Okay, and then if you talk about the density, then you'll get the density graph in this one. Now you're looking density, how much does it dense? Okay, and if you're not interested in the histogram, just deselect it and then select the box plot. You will get the box plot. So box plot is basically a 5-number summary where the 5 numbers are there. So now here, this is the, so now we call is a box plot is a box and whiskers. So now this one is our box and these are our two whisker, upper and lower whiskers are there. This one line shows our like the average, and then these are the two quartile are there, and the first part is and the last quartile. So that's why we call it is a 5-number summary. This is also showing you that either there are some outliers in your data or not. So you are looking, these are the outliers. And then if you go up, especially here you look, so these two outliers are there. And then another technique is the violin. If you select it, then it will create a violin like the there's a musical instrument. So now these violins have been created over there. So now this like the perfect, there is no any issue with this data. That's why the perfect violin is there. So now if you want to see the data, so now data you also find here data and jitter data. So now these dots, basically these are our data. But if you want to check another one like the stacked, now then the stacks also there. So now 1, 2, 3, and 4 stacked are there. Okay, and then if you are not interested in the box plot, then deselect all these one and go into the bar plot. If you just select it and the bar plot, now see our bar plots are there. Strongly agree, almost these are 28. Disagree, these are almost 32. And neutral, these are I think 25, 26 or 25. So the most of the respondents, they are agree with the statement which has been asked from the respondent. Okay, and then if you come down QPE, then you are looking the 1, 2, 3, 4, 5, 6, and 7. So here there are the 7 like the replies are there. Here there are the 5. Why? Because these two are the outliers. So strongly agree from strongly disagree to strongly agree, but the two additional are there, 22 and 44. So these two are the sure outliers in which are available in your data. And then you come down in this way, you can find out. So one method was box plot. Another method is your bar plot to identify the outliers in your data. Again, this is another outlier because we are using a 5-point Likert scale, so there should be the 5 bar. So 1, 2, 3, 4, 5 bar. But if there is more than 5 bar, that means you must be conscious that probably there is a. But even though you can say that surely there's an outlier. Okay, so now in this way you can perform all the. And last one is a QQ plots. So now QQ plot for everything has been wired. So now QQ plot. Okay, so now the almost that means both of the data we have computed, like our descriptive statistics and the, like the sum graphs. And if you are interested in the Pareto chart, then again you can also do this one. Just like you can do the okay. So in this way you can get a Pareto chart. Okay, And then another thing, I'm missing another very important thing. So that's about the descriptive statistics. And okay, what data we have to go up. Okay, few things we have to should transfer. First, we have to transfer all these one here. Okay, and then from here we have to make the gender. Okay, a gender we should send back, and now we want to select it again, and then we want to move into the split. Now we have to split the data by the gender wise. So here that is data has been split, results has been split by the gender wise. So now the n number of observations are male are 198 in the QPE and the 68 into the female. These are the female, and the missing known female mean for the male is a 3.5 in female. So in this way, whatever results which are there, you will get like the gender wise. So if you are not interested in the gender, then age. If you want to like to get the results on the basis of the age, then you can also do this one. Okay, so in this way, the age wise results are there. So any other one, for example, you want to get the education also, then move it. Okay, and then bring the education here, and in this way you are getting that the both like the through the age wise as well as the education wise we are getting the results. Now this is education and this is our age. So now it's really a wonderful, really is a magic that is quickly we are computing everything within no time. Now we are using the same like the data set with the in the SPSS, but before this one I want to remove these two things. Okay, as we should have the clear understanding of our data. Okay, so now a few things I want to compute, like the range, like the skewness and kurtosis. Okay, mode. Now these things. Now the same data I'm going to working on the SPSS. So now here is analyze descriptive frequencies, because there I'm also counting the frequencies, and then just select each and everything, and then saying the ID back, because we're not interested in the ID. So this is so the display the frequencies table. If you uncheck it, then you will get only descriptive, not the display of the frequencies table. So now we are not interested right now in the frequencies table. Just go to the this statistic. So now the center of means of central tendency, mean, median, mode, sum, and the distribution, measures of distribution, skewness, kurtosis, measures of dispersion, standard deviation, minimum, maximum, range. So now we've selected. So if you are interested in to compute the graphs, you can also like the we are interested in the histogram as well as into the show the normal curve. Okay, just okay. Now it will take time. Okay, so now see the one major issue with the species. So in this one you are looking at the data. So if you want to have a result, then you have to open another file like this one. So now we open. So for the result you are required to go into another one. So now here mean 3.31 and 3.61. If you compare this result with this one, the same is there, 3.63 and 3.61, then 3.97, and then 3.97. Almost there's no any difference among between the results from the SPSS and from the Jamovi. So now the SPSS is a paid version, you have to pay for it, or otherwise you have to get it a pirated copy of the software. But on the other hand, Jamovi is completely free. There is no any piracy. You are not required to pay anything, and actual like the original software is within your hand. So that is the beauty of the Jamovi. So at the end of this one, I hope you like this lecture, because in this one we compute a descriptive statistic as well as a graph. So at the end of this video, thank you very much for watching this video. I hope like it. So now at the end of this video, thank you very much for watching this video. If you like this video, please please subscribe my channel, please comment on my video, and please inform the others that the videos are available on the Jamovi, which is free of the cost. Thank you very much.